Okay. Welcome everyone. Today we are going to basically talk about what OSPF. This slide, it does more job. It does good job on OSPF. So I'm going to use this slide for this session. So, and then if you have any question, we can send it to the chat so that it will not disturb the flow. So OSPF is one of the major dynamic routing protocols. OSPF is one of the major dynamic routing protocols. It is majorly used in the within a private network. A private network, I mean, is this. We have internet, we have LAN, and then we have WAN. We have another line here. So now, if we are connecting our LAN to the WAN, and then we are connecting our WAN to another LAN, maybe this is our headquarters, for example, this is our branch office or our partner network. So between this LAN and WAN, OSPF is not used. That is why when we were talking about OSPF, I've touched base on some of the concepts before. It is what? Interior gateway protocol. Interior what? Interior gateway protocol. It falls under this category. Before we start differentiating between types, we talk about IGP and EGP. When we talk about EGP, we mention exterior gateway protocol. That's where we talk about what? BGP. But today, we are going to talk much about OSPF. So now, if we take a look at the diagram, we'll see that OSPF will be majorly used where? On LAN. That's why it's called it interior. Interior means it's not crossing to the what? To the internet. So we need to get that area clear where it's being used. And then in the beginning, we talk about BGP. That BGP is what? Is the routing of internet. Internet is made up of different routers. It is not magic. It is organization and some algorithms, some smart kits configured. And then they link them together to send packets from source to destination. So all these routers, because of management, they segment them and make sure that different section or different neighborhood are managed by different service providers. Different section of the routers or different section or different regions are managed by different service providers. If you take a look at it, that's why one major problem we are having in Africa as of today is cooperation. Cooperation in good sense. For example, if we find ourselves, I know of Nigeria very well, I'll use Nigeria as a case study. In Nigeria, we have MTN. MTN as one of the major service providers. Now, MTN has covered most of the environment in terms of market share. Almost everybody in Nigeria uses MTN. There are some other service providers like Airtel, Etisalat, and all that. Now, you and I, we are going to go to the market as our name is ABC LLC. We want to start our own service providing businesses. We want to start doing advertisements, getting customers. We have our own databases. We have our own division or subdivisions. If we find ourselves in Nigeria, to have a large coverage, we need to dig ground from one location to another location, put router, put mass everywhere. We dig where it's not even needed to be dug, to have connectivity to our customers. That is Nigerian case study, because there's what? There's no cooperation. Every time a new player comes to the marketplace, they need to do a lot of work. But in major advanced country, we don't need that. What they need, the service provider will need, it is what? They will need sharing formula. Sharing formula in which sense? AT&T has dominated almost everywhere. For example, or Verizon. Now we are coming to the American marketplace as abc.com from Africa. For example, we want to start a business. We want to be rendering services to our own. We want to start doing that business. We need to have a client base. We need to have a lot of stuff. But now, before we do that, we need to set our platform first, so that we can test on our own that we have coverage. Now, what we need to do is to meet Verizon or AT&T, anyone we want to play with, that, okay, please, we want to do business with you. This is our name. This is our formula we want to operate with. But we don't want to start digging holes or building masses across the board. Let us put our own machine on top of a mass. We'll be paying you so amount of money monthly. Or anytime our customers' network is coming, enable them to pass monthly, we'll be paying so amount of money. It is understandable, but what is understandable between the parties. Start business will start. I didn't know, maybe the law permits or force the service provider to cooperate like that, but that is how it is done here. Or maybe in the beginning, when they are constructing their own mass, they make provision for subletting, because that is a way of doing small subletting of part of our own space. So let's move on to topic of the day. So now on OSPF, it's majorly used within the organization. Let's assume that we have 3 routers here. Most of these organizations, they are very big. They are very big. It's not like small business like home office. No, we are talking about Amazon. We are talking about Home Depot. We're talking about maybe Comcast themselves within their own small network before they allow customers. We're talking about some big company like Visa, many of those big companies like that. That is because every routers, they have maximum capacity. If you overload a router, it's going to shut down. Because it's a computer that has a motherboard, CPU, RAM. In other words, they have limitation. That is why they will now look at, okay, this capacity cannot do everything. So we put one here, we put one here, and we put one here, for example, within the same organization. So we cannot start doing static route here because of administrative overheads. We need something like OSPF. They can do supernetting, they can do redistribution, they can do a lot of convergence on their own. Some other protocol can do it like EIGRP, RIP. RIP is not commonly used, but EIGRP can do it. So now OSPF, as the name implies, is what? It stands for what? Open shortest path first. Open shortest path first. Open shortest path first, it uses some algorithm called Dikitra algorithm. Dikitra algorithm, this name, I'm thinking it was coined by Indians. This particular OSPF, it seems it was developed by Indian. I don't want to say yes or no now, but this name sound like them. Because those guys, they really go far in networking. So now, what it does, it has some metrics, which is the major what? Cost. It use metric, the metric is cost. So it use cost to calculate what? To calculate the best parts. So now, if you look at this connectivity, this is A, B, let's say C is here, D, E. This is a client, and then this is what? A server. And then most of the connectivity is between a client and a server. Before I move on, do we do three-way handshake here? Do we talk about three-way handshake? Huh?
Not yet, sir.
I don't think not yet, though. Mr. Ken, do we talk about three-way handshake?
Three-way handshake.
Yes.
I can't recall, sir.
You can't recall, but we talk about TCP.
Yes.
Yes.
So when we talk about TCP, we must talk about three-way handshake. There's no way we talk about TCP without mentioning this. This is one of the most commonly asked questions in interview.
I think when we were talking about the OSI model, that's when we talk about TCP, but we did not talk about the handshakes.
Okay. Okay, we'll talk about handshakes. So why I mentioned this is we should know that most of the connection or most of the connectivities happens between a client and a server, period. It's always between a client and a server. So the question is, what determines a client? What determines a server? Determinant is this: whoever has something to share at a particular time, that's the server. The requester becomes the client. Even what we call a client may become a server if we turn it to be a workstation. Because in a workstation, it has some capability to store some items or files. However, we have some dedicated server. like file server, DCP server, DNS, proxy, there are many. So now, based on OSPF conversation, OSPF uses what? Metrics of cost to determine where to send packet to. So now, if I may ask, if this client wants to send a packet or retrieve a packet from the server, I need somebody to tell us which part will be the best part based on the diagram. Is it from ACE to S or from ABDE to S?
I think it's gonna go ACES.
Okay. ACE to S. Any objection?
No, on my side.
Okay, you concur, the same. But if you look at it, it doesn't work this way most of the time. We do it in a lab and we'll see how it plays. The metrics will be calculated based on bandwidth. The metrics will be calculated based on bandwidth. So we have low cost and high cost. And then we should not forget that the cost is what? It's metrics. You use metrics of cost. And then in EIGRP, when we talk about it, you use the word delay, bandwidth, reliability, MTU, and some other factors. But OSPF uses what? Cost. So what determines a low cost and high cost? If, for example, this side has 10 bandwidth, and the here has what? 100 bandwidth, 100 bandwidth. This side will be considered low cost. This is where it's going to send the packet to. Does that make sense?
Yes, sir.
It uses formula of what? Metrics of low cost. It calculates the cost based on bandwidth. If this side, it has fast Ethernet interface, this has gigabyte. This gigabyte has 100 gigabyte interface. This guy has 100 gigabyte interface. This particular play will be considered best part to forward the packet than this side. That is the metrics you use. You use what? Cost. This is the formula. We don't need to memorize this one. 10 raised to the power of 8 slash bandwidth. Nobody will ask us about this on interview. We just need to know 3 things we need to know here. Number 1, we need to know the name. Open shorter path first. We need to know the name. And it's the link state protocol. I believe we have this. We talk about link state the other time, right?
Yes.
So the link state, it uses link, that is the interface connected to determine how to route the packet. It's a link state. It's not a distant vector. So when we mention anything on interview, we need just to, this one is very, very important. We need to remember that it's a link state routing protocol. This one, we don't need to, about this one, we don't need it, but we just need to know that it's a standard protocol and there is an open source. Open source means it can be used on any devices. It can be downloaded freely, configured freely by anybody. It is not restricted. That is what open source means. And then this is the algorithm it uses. And then When we look at unlimited opcants, is comparing to what? Like RIP. RIP uses what? RIP is not rest in peace. Oh. This RIP use opcant of 25. Is it 25 or 255? Either 25 or 255, anyone that comes first. This is just a comparison between RIP and OSPF using opcant. In other words, OSPF uses unlimited opcant. And then it uses what? The metrics of cost. And then the administrative distance. We know the administrative distance is what? The level of trust. When we're talking about administrative distance, we have 0, we have 1, we have other 1 before we reach 110. In other words, if there are other protocol on this route, on this routing table before OSPF, this one will be favored first. This one will be favored first before it reaches 110. In other words, the lower the administrative distance, the better. And then it says it is a classless routing protocol. It means it can support subnetting. It can support subnetting. That's what that means here. And then it supports what? Equal cost load balancing. It can do load balancing, and it can do what? That is multi-entry point, or ECMP, equal cost multi-paths. If there are 2 routes to the same destination, this algorithm supports it. That is, we want to use it as a load balancing. Okay, we configure OSPF here, we configure OSPF here. Now we can now use administrative distance or some other metrics to determine if this one is done, let it follow this side. That is ECMP or load balancing formula. That is that. Another thing we need to know is this. These are the stages. The stages of what? Where we are troubleshooting or we are looking at OSPF. All these things, we will see it when we are doing the lab. When it is done, initiate, two-way, it starts, is exchange, loading, full. The one we need to pay attention to is just this full, done, and then what? It can be when it's in initial stage. We know, we see it when it's in initial stage. But these measures, the number 1 and number 7 are the most important part we need to pay attention to, because when the interface is done or when the OSPF is done, we see it that, oh, OSPF is not up yet. All this algorithm, all these steps, we may not see it if we don't do like packet capturing, or we don't do what debugging. We may not see all this. Or if you are not the one that configured it from the beginning, we may not see all this. Well, we see all this when we are doing the lab. So, and then when it is full, it means it has established neighborship with its neighbor. It has fully established neighborship. That is, convergence has taken place. Okay, let me see what is the next slide. Okay, the next slide, which is what we have touched base quickly now, is talking about the stages. And then this example of the configuration, this is router 1, this is router 2, and then we configure OSPF on these 2 interfaces. This interfaces is serial link. All this one, they are not existing no more. They are not usable like before. These are serial link. They have very small bandwidth. Now, most organizations use gigabytes. They use gigabytes. That has Mbps. 1000 MPS is 1 gigabyte. 1000 Mbps is what? 1 gig. So now, if we configure this link to be OSPF configuration, these are the things that will take place before the convergence take place. See, he said hello, hello. So there will be what? Initial stages, and a two-way handshake will be sent. That is, the link sent this, and then the reply comes from the neighbor. So the neighbor is, you see, in the first packet, all the information of the neighbor is sent. Say, oh, I'm using this number. Because this side is not known to the neighbor. It's sending it to the neighbor. And the neighbor too is sending this part to the connected neighbor, which is through what? Through unicast. We talked about unicast before. Because the two places they are connected link. But where it's not connected, which is a remote network, they need to advertise it to their neighbors. Downstate is when the connectivity has not taken place. This is initial stage. This is two-way, when the two neighbors exchange some of information. We say they become neighbors, build neighbor table. So let's move to the next slide. Okay. OSPF router ID. You see, router ID is it's optional, but it is best practice. What it does is just for identification. Just for one identification. It doesn't play any role in making the route to forward or not to forward. It's what? If you look at here, we see used to identify the router inside the OSPF database. By default, if we don't put router ID, OSPF will select the IP of the interface to be the router ID. Okay, OSPF identify using same ID in all directions. Yes, that is, if you have OSPF 1, OSPF 1, both of them will use the same metrics as 1 to connect. We can't have OSPF 1 here and have 2 here. Okay, default uses highest IP address of active physical interface. Okay, this one, it means that the active interface or the one that will become border router or the leader in the system will use the highest what? Highest IP. This is the router ID for this. What it also means is this. For example, now if we look at these routers, we have 172.172.16/16, 202, and 10. Among all these routers, let us mean that we did not specify our router ID. That's why this guy said default. You know, I said it here that if we fail to configure or specify our router ID, the OSPF will use one of the IPs to represent the router as a what? To identify it. So, but let us mean we have 3 connected interfaces. One of the interfaces IP, which is this one, will be used as router ID. It doesn't have anything to do than identification. Because if you look at this, 202 is the highest number 172.16, 10 dot something. 10 is lower than 172. 172 is lower than 202. So 202 is the highest IP. Sometimes you may have this tiebreaker 192.168.10.5. The same way 192.168.10.6. Dot 6 is higher than dot 5. Dot 6 should be used. Okay, let's move to the next slide quickly. Okay, exchange start, and exchange stage. These are the formulas. So these are the messages they use to stand the OSPF communication. And then we should not forget that this hello messages is sent across the board to propagate information. Hello message will be sent in the beginning, hello. And then if the other side reply, they will not start building their routing table. Yes, all this one is just formality. But we just need to know that in the beginning, there will be hello message sent between the two routers, and then they form neighborship. And these are the things they do. They share what? Database. And then they share what? LSA. One of the most important part of OSPF is LSA. This is link state acknowledgement. So they send advertisements. They advertise themselves to the other neighbor. This is what I have. This is what I have. And then they build the neighborship. One important thing about OSPF, I would say it was, let's hold on. Let's move to the next slide. Okay, this is configuration. I don't want to do that configuration today. This configuration, this is still configuration. Okay. Okay. Let's talk about this one, and then we're going to call it a day. And then if you have any question, we have, and then we call it a day. Then tomorrow, hopefully, we do the lab, and then we test. Anything we do here, it's the best practice, and then it is obtainable in the industry. It's no guesswork. So we should try to understand it to the best of our knowledge. So knowing it is a plus. So now, like we all know about one common feature with all these routing and routing protocol is they all have what? Database table. They all have what? Database table. So if you look at the OSPF, is LSA, link state database, link state advertisement. So they build this table with their neighbors by doing what? By exchanging routing information. They say all router must have the same database. What it means is this. Okay, let me use this analogy. I used it before, but let me use it now. Let us mean that we are 5 here, 5 of us, we are going to where? We are going to the beach. We are going to a park. We are going to a park. So along the route, we reach one particular place, we see a flag, say what? Detour. So we follow the detour because maybe there's a construction going on here. And if the detour goes like this, it goes like this. So we follow this store, but what we meet here, if it is EIGRP, for example, what it would do for us is this. Let us mean as we are moving, we reach this particular place, we meet a man. Say, oh, please, we are going to a park, one particular park, maybe park A, in one particular environment. Oh, park A, I don't know the place, but my friend does. Maybe his friend is here. So you will now link up to his friend. When we meet his friend will say, okay, I don't know the place. My other friend does. We meet the friend again, and then, okay, you can go here. So EIGRP will just link us to the next available route or router. That is EIGRP for us. But in terms of OSPF, they form what they call topology. They form complete topology. This is example. They said OSPF, the metric they use in GPS. They said that's what they use in GPS. That's metric. Because what OSPF does is it collects all the available routes on its routing table. The same way we are going to the park. So there's a construction going on here. Immediately when we reach here, it will tell us where to follow to our destination. Now, if you are leaving our house now, maybe we are moving from our house to like gym. Maybe we are going to one gym in within our neighborhood, or we are going to a restaurant for the first time. Immediately we put the address, or it already know the source, which is our location. So the destination address is put. It will not give us the available route to that destination. That is the same pattern OSPF does, sending packets. What it does is it collects all the routing information from the other routers and put it in their routing tables. It collects what? All the routing information. For example, this router, we know everything about this, we know everything about this, we know everything about this, we know everything about this. The same thing, this one, we know everything about this. In other words, they complete what? They form a complete map. They have the network diagram in their database. They always do what? They have network diagram in their database. In other words, if you look at what is written here, OSPF database contains information about all the possible routes to the network within the area. It contains what? It contains all the possible routes to the network within the area. In other words, GPS is a good example. So that is all. Let me check the next route if you have any information. Convergency. So, okay. I've talked about the convergence before, but let me reiterate it. Convergence is what? Convergence. Convergence, from the word converge, is to gather or assemble. So what it means is these two neighbors, they will form neighborship by convergence. But that is, periodically, they send hello packet, and then there are some other metrics we can set manually. But if you look at here, we see convergence rate is what? Is fast, about 40 seconds, 40 milliseconds. So convergence is that they form a neighborship. They form a neighborship, and then all their routing information is put on their routing database. All these things I'm saying now, it will make more sense when we start doing the lab. Another concept we need to pay attention to is the area concept in OSPF. area concept. I've touched based on some of this concept before, but we need to talk about it now again. OSPF use area concept to do what? To reduce number of updates that will be sent so that it will not be overwhelmed when there is a change in the network, because there will always be a change in network. So area 1, area 2, area 3, no, this is router 1, router 2, router 3. So now this 3 router can form an area. And then we shouldn't forget that we are talking about, when we're talking about routing protocol, we're talking about the interfaces that are connected to it, not the whole router. When we're talking about routing protocol, we're talking about the interface, not the whole router. Why I say is this? Because another interface may connect to something else, maybe a passive, maybe static, maybe something else entirely. So if this interface is playing OSPF, they will form neighborship, and then they must belong to particular area. And the one major area we need to know much about is area 0. Area 0, which is the backbone. Area 0 is the backbone. Why is the backbone? Is the first area that other network will connect to within the organization. We can have any other area after area 0, but we can't have any other area apart from area 0, ideally. That is, area 1 can connect to area 0. Area 2 can connect to area 0, which is the backbone. But let's assume we don't have area 0. Area 2 cannot connect to area 1 to have the update or to be like the like a station. Because when the traffic is coming, the area 0 will be the one that will like disseminate information. It knows where to route to, and then you know where to send a particular packet to. Another thing we need to know is this one are just for theoretical part of it. That is, between these routers, there will be the leader, there will be a deputy. There will be a leader, there will be a deputy. Why the leader? Why the deputy? It's just to maintain, to reduce some consumption of CPU. To reduce, because many of them will be sending a low packet. When they are sending a low packet to each other all the time, they will consume their bandwidth, and then their capacity will be overwhelmed. So they elect a particular router. Maybe they elect this one to be what? Border router. Or they call it designated border router. Backup designated border router. This designated router will be the leader. When it's trying to send a packet to everybody in the area, it makes sure that every participant in that area, they are alive, and then they will be exchanging hello package all the time. But why the designated router comes handy is this: in case there is change, it's the one that will first know and update others. Because if every router in the area, they keep updating themselves, there will be too much overheads. So the designated border router will be the one that have all the information in case there is change in the area or in the network. And then in case the border router or designated router is down, the backup will become the next. They do this election automatically. We are not involved. There are some metrics they consider to do that. So we need to know that we have designated border router and then we have backup designated border router. So, and then we have incremental updates, periodic SNLO and all that. All those ones, they are just theory. But the important thing we need to know is OSPF is a link state, and then it uses shorter pass algorithm to send hello, and then it is area-based routing protocol. Issue with maintaining large OSPF, or this one. All router will have the same database. All this one are just theory. You don't need to waste time on this. Okay. Issue with maintaining large network. Okay, this is example to showcase how OSPF is being designed. If you look at it, like I was saying before, this is our OSPF area 0, which is the head office. We can see that other one connected to it. It did not connect to other ones. So area 0 is the backup. And then area 10, area 20, area 30, they all connect to what? To the area 0. And the area is a logical what? Is a logical grouping of what? Routers. So when we group them logically, it reduces overwhelm, it reduces the consumption of router. And then, because when they send updates all the time, if they are always sending to themselves without getting an area, there will be problem. So they come with this kind of concept to reduce efficiency and management of the routers. And then if a particular router is not in area, is not in any area, it will not participate in the OSPF. So all area must have same database within an area. Any change in database advertised to all router within the area. We've talked about this one before.
But in this quick question, sir.
Okay.
Back to that place now. In that area, do we have the governor, the deputy here, right here?
Say that again.
In this topology right now,
yeah.
Do we have because you last said there's governor and deputy. Let's assume there's a kind of
Yeah. They have the designated.
Yes.
And they have the backup.
For right here now, do we have
right here there must be, but I cannot say this is the one, this is the one.
Okay, I got you.
They will select themselves based on certain metrics, either from the ISIP or the uptime.
Okay.
I hope it's clear.
Yes.
Okay. When we are doing the lab, it will paint more pictures. Okay, let's go to this next one. You see, concept of areas. Area is logical grouping of routers. All router maintain the same database within the same area. Any change impact all the area within the same area. All this one. So minimize size of this. All this one. Advantages of OSPF: open standard, no upcount. Disadvantage: consume more CPU resources, complex design rules. If you look at here, you see one of the disadvantages is this: consume more CPU resources. Because all the router will keep sending updates to each other in case there is what? There is a change. And then in every minute or every seconds, there will be what? Hello message to make sure that I know that my neighbor is up and running. Immediately the neighbor is not responding to hello message, it will be considered dead, and then the routing information will be updated. Okay, the same thing I've said. This is a slide. You said area design rules must have one area core. Must, you see, must what? Must have one area core, area 0. It is backbone area. All non-backbone area must connect to area 0. Area 0 must be transit area. At least one area border router connected to 2 or more areas. Interface of both router facing must be in the same area. I've touched base on that. If you look at them, see this topology. We have area 0, area 1, area 2, area 3, area 2. They all connect to area 0. And then what this means is this area 0 must be the transit. That is, if we are connected to ISP, for example, this area 0 will be the one that we send to the ISP. So when traffic is coming in, area 0 will know where to send the traffic to. I hope it's clear.
Yes, sir.
Okay, let's move on. Okay, another thing we need to quickly check is this. I've touched base on this, but all these are just theoretical part of it. So election, there will be election between the routers role, and then preemptive group virtual MAC address support. So it supports IPv6 version 2, version 3. Yes, it supports by default. All this one is what? This is HSP. HSP is what? It is when we are doing high availability in a Cisco environment. So highest election is done by what? Highest priority or highest IP address is tiebreaker. So now, based on your question you asked before, you said which one would be the what? The designated and the backup, right?
Yes, sir.
So now this is the tiebreaker. This is the what we determine that is the highest IP address or highest priority will be used. I hope it's clear.
Yeah.
Okay, let's move on. Okay. The multicast group address, load balancing standard. All these are just, you don't need to know much about those ones. Okay, this is one of the lab I want. Okay. Okay, access control list. We'll talk about that one later. Okay, this is not part of OSPF. This is where the OSPF issue. Okay, this is where it stops. This is where the OSPF market stops. So on these parts, these are the small metrics we need to know. They make election, a router role, preemptive, and then grouping. All this one, we should just forget about it. What we need to know now is OSPF does election to select data what? Designated router, and then the role of, okay, active router backup, all this one. We don't need. The role is between, we have membership of designated router and a backup designated router. And then just to recap quickly, OSPF is a link state routing protocol, and then it uses area to group the routers within the network. And then there will be a kind of link state advertisement sent before the convergence will take place. Those are the basic part of OSPF. So now, let's quickly do something now. Let's go to a line. and check likely OSPF questions. Can you see my screen?
Yes, sir.
Likely
Yes, sir.
OSPF interview questions. Interview question on OSPF. Okay. These are the interview questions. See the first one, say, what is OSPF? They can never ask that one. Nobody can say what is OSPF. They can only ask, do you understand, do you know how to configure OSPF? The answer should be yes. So now, if you look at this, this is just a basic questions. They may not even ask any of these because it's too elementary. See now, what is router ID, which we'll talk about now. What is adjacency? Describe the different router type, which we will talk about, designated and backup and non-designated. What do you think IP OSPF transmit delay is used for? Do we need any special command to run OSPF? Describe the role of topology and routing table in OSPF. This is when I use OSPF as an example of GPS. And the differentiate this, name the different network types in OSPF. This is not even good question per se. Let's look for good questions. That's why reading interview question. Okay, go ahead.
Yeah, you said if no router ID, one of the IP will be used. So how do you generate router ID? So you don't need to go, so you don't need to use any of the IPs available.
This is what I said. I said if we did not configure, okay, this is the OSPF router, OSPF, let's say area 0, right? This is the first command. The second command would be IP or router ID. Router space iPhone ID. We now specify the ID. The ID can be any number we want, but it must be 32 bits.
Okay.
So now if you fail to run this command, OSPF by default will now select the highest IP on the router interface.
Yeah. Okay.
And then what is router ID? It's just for identification of the router in the routing table. Is that clear?
Yes, yes, yes.
Okay, let's move on. So this is indeed. So these are the questions that we may come across during the interview. So let's see the first question. What do you do if you notice that OSPF neighbor is in downstate? What do you do? This question is majorly for network engineer guys. But if it's in the downstate, okay, before I answer the question, what can somebody do at this node? If the network is if the OSPF is in downstate, the answer the guy put here may not even be correct. Or it may be correct. But let's see. Can anybody try?
Yeah. Yeah, I think you go through the backup stage. If one of them is down, according to what you said, No.
You are talking about election now, but with this place, they are talking about if now two routers are connected. You now check your router, you see that it's in down state. You are not talking about, okay, you have two parts. If you have a two part, you are setting traffic. If this side is done, it will follow here, fine. But what about if this one, we don't have any other part, we have only one link to another link. No, there's no alternative route. And then this interface, this is 1, this is 2. On the one side, it shows done. What are we going to do? All right, give me 1 minute, let me use this myself.